So welcome to day 3. We are going to do some graphing. We did a little bit in day 2. I showed you how the graphs kind of worked out, but today we're actually going to graph, a requirement that you will need to have for your assessment. I don't know why that's so weird. Okay, so we're going to graph both exponential growth and decay. Before we get into that, let's kind of review our last lesson. What's the difference between linear, quadratic, and exponential? So I will start with the equations for linear. So linear is mx plus b, where your exponent is 1, or as you can see, there is no exponent here, and it graphs a straight line, arrows on both sides. Quadratic is something squared, something to a 2 exponent. So ax squared plus bx plus c. And a, b, and c can be any number as long as we have this exponent of a 2. That will give us a parabola. Our chapter now is focusing on exponentials. So there's 2 different kinds. There's growth and decay. I will graph a growth. So one example could be 2 to the x. Your exponent is the x. That's how you know it's exponential. And I'll graph growth, which looks like this. And it has a horizontal asymptote, which always has to be shown in these problems. Okay, so how do we graph it? We had this slide yesterday, so we've got exponential growth and exponential decay. The big stuff I need you to know. Growth factor bigger than 1, so y equals 2 to the x, y equals 3 to the x. Anything bigger than 1 will give you a graph that looks like exponential growth. Okay, numbers that give you exponential decay, that get smaller as it goes, as the x's get bigger, are half to the x, 1/3 to the x, 1/4 to the x. Any number that is in between 0 and 1 gives you exponential decay. This number, this a in front, stretches it a little bit, but its basic shape comes from that base being a 2, 3, 4, or a 1/2, 1/3, 1/4. Okay. Exponent rules that will help us. So the big exponent rule that you need to remember is your negative exponents. What happens when you have a negative exponent? Negative exponents make a fraction. So 2 to the negative 1 is equal to 1/2. 3 to the negative 1 is equal to 1/3. 2 to the negative 2. 2 squared is 4, so 2 to the negative 2 would be 1/4. 3 to the negative 2 would be 1/9. The negative exponent makes a fraction in this case. I shouldn't write that because it's not always true. Okay, so let's see what happens when we have negative exponents with fractions. So let's write negative exponent is a flip. That's probably a better thing to say. Okay, so half to the negative 1 is 2. It flips 1/2 and makes it 2. 1/3 to the negative 1 is 3. 1/2 to the negative 2 is going to square everything. Well, 1 squared is 1, 2 squared is 4, and flip it. 1/3 to the negative 2 squares the 3 and flips it. Okay, so whole numbers become fractions, and fractions become whole numbers with negative exponents. We'll keep that in mind as we graph. Here we go. We're going to graph 2 to the x. 2 to the x is growth. As x's get big, our graph should get bigger. So let's put x and 2 to the x, and then we'll graph 2 to the negative 1, which is 1/2. So negative 1, 1/2. Oh, this graph is tiny. 2 to the 0, anything to the 0 power is equal to 1. And 2 to the first is equal to 2. Okay. Now, I'm going to add some numbers here. 2 squared is 4, and 2 to the third is 8. So we're going to continue to double. So we'd have 4, and then we'd have 8, and then we'd have 16, and it gets really big really fast. Now, as you go the other way, you're cutting in half. So I have 1, and then I have half, and then I have a quarter, and an eighth, and a 16th, and a 1/32, and it's going to continue to cut in half, but it will never get to 0. It will never get to be a negative number. So it's going to get really close to that x-axis without crossing, which is why I said to make sure that you're putting in a horizontal asymptote, because it does not cross that horizontal asymptote. Okay, our horizontal asymptote is at y equals 0. And this function goes through the point 0, 1, and you're going to find that for all exponential functions before they do transformations. Okay, let's do 3 to the x. 3 to the x. I always set up a table. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the third, or 3 to the first is 3. So we've got 1/3, 1, 3. You can see it looks really similar to what we just did. We're going to have something really close to the x-axis. And then we've got our horizontal asymptote here. See, it goes through this point, 0, 1, and our horizontal asymptote is at y equals 0. Okay, moving on, 4 to the x. I think you're going to see the pattern now. We've got 4 to the negative 1, which is 1/4. 4 to the 0 is 1. 4 to the first is 4. 1/4, 1, 4. Very similar. These are all examples of growth. The bases are all bigger than 1. Horizontal asymptote is at y equals 0. Now that will change. Once we introduce our transformations to this, our horizontal asymptote is going to move as we transform them. But for now, we're just doing the parent functions. Okay, in the 3 previous graphs, they were examples of exponential growth. What did you notice about each graph? They both had a horizontal asymptote at y equals 0, and all 3 of them went through point 0, 1. All 3 of them. What did you notice about each equation? Each equation had an exponent that was x. They were all exponential functions. And what did you notice about each table? Every table had fractions and whole numbers or integers. Okay, so let's go into decay. We've got, I like to write this as, instead of 0.5, I like to write it as half to the x. And again, we've got our negative exponents. Half to the negative 1 is 2. Half to the 0, anything to the 0 is 1. And half to the first is half. So let's graph that. Negative 1, 2, 0, 1, 1, 1/2. And then I'm going to continue to cut in half. Half times half is 1/4, 1/8, 1/16, 1/32. I'm going to continue to cut in half over and over and over again. I will never get to 0. I will never get a negative number. And then I'm going to complete the left-hand side of the graph. So decay also has a horizontal asymptote at y equals 0. The difference is, as your x's are getting bigger, your graph is getting smaller. Okay, let's try it again. I hate the decimal, so can we change this to 1/4 x? It's much easier to see 1/4 to the negative 1 is equal to 4 instead of using that decimal. 1/4 to the 0 is 1, and 1/4 to the 1 is 1/4. So similar graph to our last one. We have a horizontal asymptote at y equals 0. Okay, last one. I'm going to change this. 0.3 repeating is the same as 1/3. So let's change that to 1/3 to the x. 1/3 to the negative 1 is 3. 1/3 to the 0 is 1. 1/3 to the first is 1/3. So I have negative 1/3, 0, 1, 1 1/3, and I graph, and I have a horizontal asymptote at y equals 0. Okay, so all exponential decay. What do you notice about each graph? Well, each graph had a horizontal asymptote at y equals 0, and each graph went through 0, 1. Every single one had the exact same equation for asymptote and y-intercept at that point 0, 1. Okay, what do you notice about each equation? That they all had a base and then a exponent. And we should say that in all of our exponent that was an x in all of our growth, that meant that also that the base was bigger than 1, where in decay, the base was between 0 and 1, or a fraction, or decimal. That's between 0 and 1. And what do you notice about each table? That there are fractions and whole numbers. Okay, so go ahead and instead of doing a Schoology quiz, we decided that a worksheet is going to be more effective. So go ahead and do the worksheet. Most of the answers can be found on this video. Please make sure that you are as accurate as possible, as I will be grading a handful, not the entire worksheet, but a handful of them for formative points. Good luck. See me on Google Meets if you have any questions.